Here we are given two functions, f and g, and asked to find the composition in both directions and then use the inverse function property to determine if the functions are inverses of each other. So first of all, we will look at the composition of f with g of x, and that takes x to what f takes g of x to, where g of x is the log base 1/2 of x minus 6. So f of the log base 1/2 of the quantity x minus 6. And what does f do to anything? It exponentiates what it sees, base 1/2, and adds 6. So we'll have 1/2 to the power log base 1/2 of x minus 6 plus 6. And 1/2 to the log base 1/2 of anything, those two functions neutralize each other and you get left with whatever the input was, and so that's going to be x minus 6. We add 6, and so the 6's neutralize each other, and the result is x. So the composition of f with g of anything takes that to itself. Composition of g with f of x is the same as what g takes f of x to, where f of x is 1/2 to the x power plus 6. And g takes the log base 1/2 of what it sees and subtracts 6. So log base 1/2 of the quantity 1/2 to the x plus 6 minus 6. It's the log of that whole expression, base 1/2. So the first thing that happens is the 6's neutralize each other and leave us with log base 1/2 of 1/2 to the x, and the log base 1/2 undoes exponentiation base 1/2 to leave us with x. And so we can say f and g are inverses, since the composition of f with g takes any value to the same thing as what the composition of g with f takes the value, and in both cases the value is taken back to itself. And that's the condition necessary for the inverse function property. In our second example, we have f of x equals 3 to the x and g of x equals log base 3 of x quantity plus 1. So the composition of f with g of x takes x to what f takes g of x. And g of x is the log base 3 of x quantity plus 1. And so f exponentiates what it sees base 3. So we have 3 to the log base 3 of x plus 1. And you remember that a to the m plus n is equivalent to a to the m times a to the n. And so this expression is going to be equivalent to 3 to the log base 3 of x times 3 to the first, which is going to be equivalent to x times 3, since log 3 to the log base 3 of x is x and 3 to the first is 3, this would normally be written as 3 times x. On the other hand, the composition of g with f of x takes x to what g takes f of x to, where f of x is 3 to the x. G takes the log base 3 of what it sees and adds 1. So log base 3 of 3 to the x plus 1. And log base 3 of 3 to the x is x, so we end up with x plus 1. So we can make the conclusion that f and g are not functions. Since composition of f with g of x does not equal x, and the composition of g with f of x does not equal x. If either one of these did not equal x, the functions would not be. I said they are not functions, or I wrote they are not functions. I hope I said that they are not inverses.